Hello and welcome to week 5 demo on Python. Again, as I stated in the lecture, it's kind of hard to differentiate Python from EDA, but they are very different things. At the end of the day, Python is a tool, where the EDA, exploratory data analysis, is a method. Methods can be done by Python, Tableau, Tableau Prep, R, C, Ruby, any of these languages. When you do EDA, which we'll go into next week, it's in some ways more about the statistical understanding of the data. You want to know if the data that you have is fundamentally valuable to answering your question. Python is a tool in which we can use to do that EDA. We can use to generate reports. We can use to generate PDFs and many other things. Now, in many ways, these things, EDA and Python, when I say these things, go hand in hand. Python for a long time has been one of the primary tools to accomplish EDA, and Python has been one of the primary tools to do data analytics, data science, even business intelligence for many. Now, there is no one right method, one right tool, or anything else like that. So please keep that in mind. I would like to go over, in the demo, I'm going to go over a couple different things, but I want to show you what Python can kind of do and give you some code, some sample code that you'll use for the homework that's due in, it's like October 8th, I think. So week 6 is when the homework is due. So there's no homework for week 5. Again, you have your report that you got to do, your proposal. So I want to give you homework, but the tools and the knowledge you gain from this demo, you'll have to bring forward to week 6 to work on the EDA tools. When I was going through Google Colabs to show you how important EDA is, or let me diverge a little bit. Next week, we'll learn that one of the key importance of EDA is visualization. It doesn't matter if it's a bar graph, and we'll go over that today heavily in the demo, because today's demo is a lot of EDA. Because we can use Python to do EDA, which is pretty much the demo. The next week, we can use maybe Tableau or Tableau Prep to do EDA. But today, we're going to use Python to kind of explore our data and connecting to an SQL server. So if you go to the Google Colab blog, well, the first one is, hey, we upgraded, we spent a lot of money and we upgraded to a new version of Ubuntu. And nobody cares. The second one is Colab Data Visualization Made Easy, this article right here. And why this one piqued my interest is because it demonstrates how important both EDA and visualization is in Python. During the lecture, I expressed, and maybe I didn't express it strong enough, that notebooks have fundamentally changed the way that a lot of people do programming, and a lot of Python programmers and R and other languages interact with code. And this is kind of related to that. Here's a sample notebook. Let me just load it up here real quick. And so one of the fundamental things when we write Ruby or Python traditional terminal script is that we get a big long output. Hold on one second. Let's figure out what's going on. I just grabbed another notebook real quick. But when we write in traditional Ruby, Perl, Bash, Python script, it's just a long line of code. It's just a lot of list of code. Now, sometimes we import other pieces of Python, but at the end of the day, it becomes hard to debug. It's hard to visualize. If I was doing this in a Python script, this would be saved to a file, or sometimes it pops up in the window. But it's hard to see what's going on. Okay, and this is, I think, still running in the background. But one of the nice things about a notebook is, here, look, I can make this bigger. 600 times 9. Instead of running the whole thing, I can just run this part of it. Much bigger. I can add notes. I can add a note right here. Made larger so people can view it easier. Make notes bigger or bold them, or I can make links. And I can spell things right. So you see there's a lot that can be done with a notebook. I just want to make sure you understand that notebooks are, at least right now, a lot of the future of data analytics, business intelligence, data science, because it gives us a way to break up our code. It gives us a way to do things much easier. I'm going to post this link. This is another link I found, which I fell in love with. It is a curated list of Google Notebooks. I believe that notebook that I just had is from this list here. But you can see, if you're interested in data analytics, here is some notebooks you can run. So you just literally click on it, and it runs that notebook. So it loaded this notebook, and it just gives you all the details. Here's where you put your API key. There's a lot of great notebooks curated by Google. Data visual. This one's the one I was just running. Chemical structures. There's an EDA one. Colab Primer Fun. Just click it, and it's a great way to learn, or not learn, collabs. So we did talk a little bit about Scikit-Learn. Let me pull that site up. And I wanted to do a couple of demos on Scikit-Learn, just to download and to learn how to basically put something into Colabs, because somebody asked me that. So here is the Iris dataset. Literally just click it here. It tells you kind of what it does and things like that. This is really short, so I'm just going to click down here to the IPy notebook. It downloads it. And I'm going to put that on my desktop. I know you can't really see it. Oh, it's on my desktop right now. But I'm just going to go back to notebooks. And then you can either hit upload here, but basically just upload notebook. Actually, let me move this. Okay, maybe this might be a little easier. Go File and just upload the notebook. And literally, I'm just going to drag the notebook on here. This was that one I just downloaded from Sidekick. And this is the same way that you'll access the script I give you. I'm just going to run all because I trust this data set. I know about this data set. And you see that basically it runs and does everything that this does. And so when you want to have one of your own data sets and run it through a decision tree, for example, just download it and File, Open, or you do New, it doesn't really matter. Plot tree structure is just kind of a weird name. And then here where it says dataset load import iris, instead of doing that, I can import my own data set and basically run it through the same code, which is really nice. Boom, little decision tree. Great little sample code. Great place to start building from. Okay. So now let's go into today's code. I'm going to have to change my password because you'll probably see my SQL password. But I do always want to express that, notebook, when you, where's my connection demo? Actually, we'll do this one first. When you share notebooks, and this could be uploaded to GitHub, this could be share it with the coworkers, and you have credentials in there. And the credentials could be a couple different things. It could be a name and password as what I sent you. earlier this semester. It could be an API key that's, well, any API key. Like, I don't know if I have it in this one. I don't. That when you share notebooks, either to GitHub, to anywhere, and you have credentials in them, expect them to be leaked or stolen. There are hacking groups and people that basically scan GitHub all the time for API keys. LinkedIn, they scan code on LinkedIn for API keys or names and passwords. And you'd be surprised how often people will upload something, even if it's just really quick on like Gist or GitHub with a name and password in it, and that gets leaked almost instantly. So just always remember, if you share something, to kind of block out your password or use better practices. One way to do that is put your names and passwords in a flat file and basically have Python reference that file and not upload that file. Okay. So that's my spiel. Don't upload things with names and passwords in it. So I'm just going to hide it right here. I made a really quick notebook to connect to the AWS MySQL server. So we have to think about the data flow here for a second. We have an Amazon AWS MySQL server. So Amazon, in the physical machine at Amazon's data center, is hosting MySQL data, is hosting SQL data. That's being transferred over to Google, Google.com, Google's machine for processing. So the advantages of that is both Amazon and Google have very, very fast internet, obviously. Also, I don't have to download it to my device. So if there's some type of security threat, some type of security problem, not including necessarily libraries or packages, that it's safe from my machine. My machine is inherently isolated. So I'm not downloading this data. I'm taking it from Amazon and going to Google. Also, I could do this on my phone and pull billions of rows. Why? Because it's actually not coming down to my phone. I'm not using a cellular link. If you really think about it, we're going from Amazon to Google. So being as such that it never comes to my local machine, it's not dependent on my internet. It's not really dependent on anything else like that. So that's a huge advantage. So you see, I have to install a package. It's just called MySQL Connector. It installs in a few seconds. Actually, that won't do it, but okay, so let me just install this. As I talked about before, Python comes with a bunch of different connectors and packages. This is just a way to connect to MySQL. Any type of MySQL connector, use this one, or there's SQL Alchemy, and there's a couple different ones. This is just a simple enough one to use. So it installed. Now we basically have to tell Python to use it. Here's my name and password. And then all we're going to do is basically just create a cursor and run that cursor and say, hey, select all from cars. I want to change it. Cars.Craigslist. So the database, cars.Craigslist, the table, vehicles. Select 100. Save them in results. And let's see what we have. Look at that. It ran, I don't know if you can see that, in 0.1 of a second. And so that was just my real basic connector. All that does is just make sure that this Google machine can physically talk to my AWS machine. Making sure there's no firewalls in the way, making sure there's no type of connection issues or anything else relevant to getting data. I mean, I pulled data. You can obviously see I pulled data. So this code now, let's save it into a data frame. Let's save it to pandas. And any type of business intelligence, data analytics, data science, literally any type of Python, you'll have to become much better at pandas. Pandas is like Excel in some ways for Python. is very, very important that we at least know the basics of pandas. Because pandas is used to do so many things. Like pulling data and storing it in a structure. So I'm just going to run this code. I've already run this down here, but I'll show you anyways. So we use NumPy, Pandas, Seaborn, and Matplotlib. I don't think you even need those for this demo. For the next one you might. But you can just comment those out. And then I'm just going to run this. And you'll see that I have the same SQL code. Select all from cars, Craigslist, vehicles. I'm just putting a limit on 250,000 pulls, rows. Okay. And it pulled it. The difference is, results equal cursor, fetch all. Data frame, okay, so basically I'm taking the results, which I saved in Python, the results, the variable results, and I'm shifting it to a data frame. And I'm just printing out the head of the data frame. I just reran this code, and it took 7 seconds to run. So 7 seconds to pull 250,000 records. So again, going from Google to Amazon, very, very fast. So a couple quick things. Actually, I should add one more here. DF columns to lists. That just tells me what I have in my data frame. Data frame, columns, to a list. So I know that I have the ID, region, price, year, same thing that I had on that to Craigslist when we were doing pure SQL. Another thing is DF shape. So it looks like I pulled 250,000 rows with 12 columns, which is what I'd expect from having that limit 250,000. So this is a really basic connector. When you use it, just change your username and your password, and you'll be able to connect to this database or any other of the database and the tables related to it. I'm going to show you one more demo of this here in a second. Before I show you that demo, I want to show you MIS report demo. I want to create, because often people think in Python that you don't do PDFs or you don't output anything else besides tabular data, and that's not true at all. A lot of what Python does is PDFs. Okay, so here is a simple notebook that I'll send you, and I found somebody else that made a notebook and just kind of changed around a little bit. But if I had data in here, it creates this little one-page PDF. I can change enrollment, I can change UNLV, Rebels. Let's say I wanted to pit. So it's hard. There we go. Just run it again. Las Vegas, Nevada. Now, what you can do also is download it. I include a little code down here. This to download it. Let's open it up. So you can see that this is Acrobat. And I just made a little PDF. Super simple. A few lines of code, you can make a PDF. And then you can send this off to your boss or whoever's interested in reporting on this Python data, what's there. And finally, see if I can zoom in here. I include a little code here from what they call TextBelt. I use this code a lot. Again, you have to have an API key, which you'd put right here, and a phone number. But basically, it will send you a text message when this code is done running. For something like this, it's not that important. However, I have code. I have one particular piece of code I have in my mind right now that it takes 3 or 4 days to run. So basically, I spin up a virtual machine at work. I start my Python code, and I just let it go. I know if I start on a Friday, I should have a text message by Monday or Tuesday. If I don't, then I can start investigating what happened, what process failed. But when you have these really long Python codes or really long Python scripts or anything, you can use this in Alteryx, you can use this in many different systems. This will shoot you a text message when your code is done. So I've also kind of included that down here at the bottom. So this is a nice little sample code on how to make a one-page PDF. Let's get into the fun part. Okay, this is a sample connector notebook. So this is basically the same as what's it called? Demo connector Python simple. First we install the pib library, like MySQL connector. I have to make sure I hide my password. So now we're just pulling from that cars data like we did before. I mean, it's the same notebook. This time we'll need matplotlib and Seaborn. Right here where it says hide my password, I basically just load it to a data frame. Okay, so actually I'll just run it right now. Oh, so that took 8 seconds to load. So now let's look at this data a little bit. Okay. I didn't want to do a demo where I just type Python because that's no fun. Basically, this looks at. Okay, so we have right now about 400,000 rows. Of those 400,000 rows, we have about 20,000 missing manufacturers. Well, if we have a model of a car but missing manufacturer, can we infer the manufacturer? What do you mean, Richard? Very easy. If I told you, hey, who makes an F-150? Ford. Who makes a blank Camry? Toyota. Who makes a blank Civic? Honda Civic. We're smart enough that we can kind of infer the manufacturer from the model. So that's what this code does. Instead of just throwing out all the blank manufacturers, we're going to try to fix that. And we end up fixing about 2,500. So then we remove all the ones that are basically blank. So we start with 17,600 that are no manufacturer information. We fix 2,500 based on basically the model. Then we remove the remaining 1,500, and it just gives us the percent of kind of the total. So let's see what else we can do. So that's your basic EDA idea. How can we fix this? So now let's look at car prices. So to me, this is useless. Why? Because if you're going to buy a $12 million car on Craigslist, you're, I don't know, crazy. I mean, maybe they're putting it there for PR. That is such an extreme outlier for a Chevy. If you buy a $12 million Chevy, let me know. There's a bridge somewhere I'd like to sell you. And maybe Ferraris I can understand being, $100,000, $200,000, but there's a $10 and $11 million, I guess it looks like $11 million and $13 million Chevy. So this basically just gives me kind of a box plot, which we'll talk about next week a little more in detail. But it's so bad, I can't see anything. So there's something called IQR. Hopefully most of you have had statistics class, and we'll talk a little bit more about statistics next week. IQR looks at the range. It gives you 5 data points. It looks at the range of your data. And then I can kind of remove any data points that are beyond the outliers. It's kind of what this code does. That's what this code does up here. So if it's above this, below that, 1.5 times 3, your third quartile, it removes it, and anything below 1.5 times basically your lowest IQR, it removes. So then it creates a new data set. And that way I still have my original data set. So basically it's like having 2 Excel files. I still have my DF, my data frame, my original data frame. I also have a new data frame called DF IQR filtered. Okay. And oh, now look at that. Now that is useful information there. As we'd expect, Ferrari, Aston Martin have more expensive cars. They have a wider tail. They have a more expensive average price, more expensive median price. But this looks a lot better. This is something that we could actually use to portray intelligence. You know, we see that, I don't even know what a Morgan is. A Morgan is considerably cheaper than a Land Cruiser. A Datsun is more expensive than a Harley. What's an Audi is, overall, the max price of an Audi and Volvo is about the same, but Audi has a higher average price. So just real quick, this would be the maximum, the most expensive Ferrari there is. This would be the cheapest Ferrari there is. I still like how we have all these zeros. You know, I might fix that down the road, but not right now. This is where, this is the median price of all this particular cells. Median price of Mercedes-Benz. Then you see here when you don't have an asymmetric, it's not really asymmetric, when you don't have an equal distribution. And so that's what I'm looking at in here too. You know, this is a good distribution. It looks like about 50% is below, 50% is above. You also want your tails to be kind of equal. It just depends on the data set. But this is a really nice chart. That was really easy to get to. So let's dive into individual. So I zoom in here a little bit. Let's dive into individual manufacturers. So I want to just grab the top 5 manufacturers. I'm just going to grab my filtered data set and say, hey, grab the manufacturers with the 5 largest. Put to the manufacturers. This is the same thing. Index to list, we did that earlier when we displayed the columns. Data frame top 5 is in our list from here. Then just show me the top 5 right here. This just basically shows a count of it. We don't have to worry about that. So here's the top 5 manufacturers: Ford, Chevy, Toyota, Honda, and Jeep. Interesting, okay. Well, let's break those down. So here's that broken down. And this one I put an average on it to kind of help you out, to help you see the difference. Okay. I don't know if it's helpful, but there it is. Okay. So now we're kind of getting a little, IQR with outliers removed. But now let's think about this. Let's make a really pretty graph. Something that, you maybe, I guess you could do this in Excel, but you want something really nice. So this is Seaborn Colors. S&S is my colors. Well, I wish I could make it just a little bit bigger. That's a really nice looking graph. That's something you could send to somebody. You can change the colors. You can do a lot of other things to that. You increase the resolution of the DPI. And again, we're basically just taking the IQRs, assigning some colors and plots to it. We're actually running the plot. Put the ticker at the bottom. That's what that line does. The title. And there we go. Beautiful chart, relatively simple. But now, let's look at F-150s. Okay? F-150s was one of the more popular models. So if I look at F-150 by model, in 2018 I have 800 in this data set. F-150, 2013 I have 854. It's sorted by largest to smallest. So what if there was a way we could kind of look at the mean price, sorry about that, and try to predict what the value of a Ford F-150 is going to be in a couple of years. This can be done in not necessarily specific years. Tableau can do, and so can Power BI, predictive analytics, but it uses just more of a regression model, okay? But basically what I want to do is, again, remove any of those crazy outliers. I kind of want to do a depreciation rate. This is our year 2023. And basically what I'm going to do is take the average current price divided by basically the max price over the number of years and divide it. And I get this. And again, I just did 2025 and 2028. So I have to double check my math here eventually. So if I bought a 2019 Ford F-150, right now the average price is $36,000, $35,000 some change. The depreciation rate is 18%, so I should be able to estimate that in 2025 that vehicle will be worth $23,000. Sorry, I'm going back to $23,000. In 2028, that vehicle, keeping the same depreciation rate, which we know is not necessarily the case, is $12,000, $13,000. One thing I did find interesting is look at the differences in depreciation rates. So a 2020 depreciates less fast or at a slower rate than 2019. A 2018 depreciates slower than 2017. 2016 depreciates slower. Is that because they're bad vehicles, bad years? Maybe they have some type of change that made them worth less, or these ones may be worth more. But you can see now we can relatively easily take a year and figure out what a car is going to be worth in 2 or 3 years. And so really, I'll give you this data set. It's really interesting. I just played around. Let me know if you have any questions. I can dig in here a little bit deeper. I have 2 other data sets I want to share with you that you'll need them for the homework. It's just easier if I change my password, but there is a, is this the accident? This is the accident one. Okay, I wanted to actually start with this data set first. This is a little simpler in terms of what it does. Again, as before, it just runs a MySQL connector package, imports MySQL, connects to the database. We'll let it catch up for a second. There we go, it's catching up. It's going to pull, now I think, let me look, it might pull all the data, it might just pull some of the data. So this is one of the data sets that deals with pilot and flight information. I thought it was a real data set, but the more I've looked at this data set, I think it's fake. And I'll explain a couple reasons why. So that's why it's valuable to look at this data set too. And you can use this data set for the homework for section 6. That's why I'm giving you the connector. There's 2 different connectors you can use, or the Craigslist is technically 3. I don't care as long as you get derive some value from it. So this is the age of all passengers on the flight. Now I'm looking at this data set and it doesn't look right to me. Why? It looks too perfect. So am I to believe that between the ages of 5 and 10 years old, you're just as likely to fly as you are between, I don't know, 25 and 30, between 40 and 45? So you're telling me that just as many 85 to 90-year-olds fly as 30-year-olds? When we talk about EDA next week, this is the type of visualization that you always want to keep in mind. To me, this is not what a normal age distribution looks like. I know that when I look at medical data, I never see a distribution like this. That is one reason I think it is fake data. I guess I should look where I got the data set from, but it's just, have you ever seen an age distribution like this? No. This is a very, if you look at age of college students, age of people that go to visit a doctor, look at the age of people who visit a pediatrician. You're still not going to see a dead people that die in car accidents. You're not going to see a distribution like this. I can think of 100 examples, and I'll never see a distribution like this. So if I was at my job and I was working, I saw a distribution like this, I would stop instantly and start interrogating before I went any further. And so, because I thought this was a real data set, I install another program and basically do the same thing. And I get basically the same answer. Now I look at this, I just ask for pandas to describe that one column. The column's called age. It tells me the mean is 45. Well, I can believe that. Most people are 45 years old. I guess I can believe that. It tells me there's about 100,000 rows. Okay. Standard deviation 25. So that means most of the people are between 60 and 20. And that's a little perfect, but okay. The youngest age is 1 and the oldest age is 90. So this doesn't really help me. So I want you to kind of keep this in mind that when I say that EDA is more than just looking at numbers, it's visualization. This is what I mean. This is a perfect example. Let's keep going a little bit more. Here's another thing. I gave up on looking at age too much because that was my first hint that this was artificially generated numbers. I looked at the number of flights that were, because I have a business question. One of my business questions I wanted to look at with this data set is there one or two pilots that suck at their job and they're always late? And then is there one or two pilots that are always on time? And if so, can I have the pilots that are on time train the pilots that are late? I'm not interested in firing them or anything else like that. I want the pilots that are doing a really good job to help the pilots doing a not so good job. That's just common business intelligence. That's something that any airline would want to do. And you can apply this to all types of things. Do you have UPS drivers that are late? Do you have delivery drivers that are late? Do you have ones that are above average all the time? Okay, so I'm just going to look at the column labeled flight status, normalize it, and look at this. Canceled, 33% of the time my flights are canceled. On time, 33%. Delayed, 33%. Something not right there. And I only have one pilot, Perry Burnhouse. He's only been late twice. That's my number one most late pilot. And my number one best pilot, the pilot with on time, is Edith Leggings. So those two data facts suggest to me that this is a fake data set. But when you do homework next week, here's some of the questions that you can answer. Again, I have two different data sets. I'm going to load the next one up here in a second. But pick two or come up with two of your own. You can also use a car data set. Which nationalities are most frequent among the passengers? Or you could just change this to nationality. What is the average, median, and range of passenger age? Well, I did that right up here. Maybe you can clean it up a little bit and run IQR. What is the overall percentage of flights that are on time or not on time? So with this one, when I typed this one up, I was thinking I wanted to do a pass-fail type of scenario. As an executive or as a person that owns an airline, all I care about is either on time or not on time. I don't care if it's canceled or delayed. It's either on time or it's not. Yes or no. So what would I have to do? I would have to take the canceled and delayed, combine those into one merged data frame, and the on time and compare those two. So again, not super hard to do, but it's a very valuable business question. A lot of times in, we'll say Uber Eats or a lot of these delivery services, they break down unable to access customer refuse, unable to locate. You have all these different metrics for management to dive into problems. But at an executive level, you want to know, did it work or did it not work? Did it work or did it not work? And so that was what I was thinking with what's the overall percentage of flights that are on time or not on time. What's the busiest month or day to fly? What's the average frequency of flights per pilot? It's around one. I looked really quick. So again, I just picked two random ones. I picked what airport has a highest passenger count. I did that one for you. And then I did, what are there any specific airports with higher passenger frequency of delays or cancellation? So in this data set, these are airports you don't want to go to. Okay. So there's basically that one. Again, some of this is basic EDA, some of this is basic knowledge. But it shows you how to connect. It shows you how to pull data into a data frame using Python, which is the goal of this. Let me load the other one that I really like. I think it will help you more in the long run. It's accidents. Let me pause so I don't get my password leaked. Okay, I think I got my, and there's so like I said, if I was to do these notebooks commercially or for something outside this class, I would probably have an environmental variable with my name and password, or there's get pass, last pass, get. Then there's a command get pass, collab hide password. Yeah, this get pass. Yep. Oops. So we're going to talk next week about pandas profiles, which is called YADA profiling. So it does a lot of the EDA for you automatically. And I kind of wanted to show that to you because it will give you a better idea when you go to attack your homework, when you go to process your homework next week on the week 6, of maybe some problems in the data. Or maybe some things that it thinks a problem that aren't a problem. Okay. So I'm installing the MySQL connector, but I'm also installing, this used to be called Pandas Profile. Now it's called YADA Profile or Profiling. We give it a second to run. And one of the reasons I'm using this package is because I just don't know a ton about this data set. I uploaded this data set, took a quick look at it, and said it's interesting, and moved on. This data set is a data set of accidents, like car accidents or motorcycle accidents, things like that. So it shows that, hey, here's the start time of an accident. Here's the end time of an accident. Right lane blocked due to accident on I-70 East. The street is I-70 East. City is in Dayton, Ohio. Zip code. And then we have more information. Roundabout, station, stop sign, I think stop light, stop sign. Traffic calming, we have wind shear, we have all types of, nautical daylight, astronomical daylight. Okay, so what do we have? I think I just grabbed 50,000 rows, and this has 38 columns. This just gives me a ballpark of what each element is. So I know I have 2 date times, some descriptions, things like this. Oh yeah, see, I said it listed as pandas profiling. I need to delete that. So anyway, so what I do with Panda profiling, I hope you find this interesting. I just downloaded. It's basically I just take that data frame and I say, hey, create a profile of that data frame. You can name it anything you want, and then save it to a file. Again, on a Python script, when we're running this on just regular old-fashioned Python code in the terminal, it just creates an HTML file. Well, the HTML file it creates here is at Google, so I have to download it. So here's that code to download it. Now, this is what hopefully you'll love. Let me open up this. And so it downloaded this. HTML document. So it gives me some alerts. So let's look at it. So you saw that I had 50,000 rows. Distinct 100%. So that's good. That means all my IDs are truly distinct IDs. That's good. Severity. Well, I only have 4 categories and none of them are distinct, which is what I'd expect. All my categories, all my distinct categories are either 1, 2, 3, or 4. I don't have any 2.5. I don't have any data errors in there, which is good. Start time, end time. So it gives you a little bit about each data set. Street. So out of the 50,000 I have 15,000 distinct streets. The most common street was I-10 West. Second most common was I-95 South, I-10 East. I'm not missing any data. So 30% of my data is distinct. It goes on and does it for every one of them. City, I have 4,235 distinct cities. Los Angeles being the most common city where accidents happen. And then Charlotte.
I found some web results. I can show them if you ask again from your iPhone.
Gotta love Siri. And this goes through and you can kind of get a breakdown of what each category is. The most common temperature, 72 degrees. So let's go to alerts. Country has a consistent value of US. So what is that telling me? That's telling me that if I look at the world, the country, I don't need to have that in there because every one of them is US. It's just basically taking out data. Turning loop has a consistent value of false. So I have 2 columns that have value or that have data that add no value. They're all the same. So if you said, hey, I'm looking for accidents outside the country, well, I don't have any of that data. I'm looking for accidents with a turning loop involved, I don't have any of that data. Okay, so you see some of these are really nice. Now, what else did I want to go into here? See, we'll talk about this next week. This is a correlation. They call it a heat map. It's a correlation plot. So what is related to, I think I clicked on city. You see how some things, again, you'd expect twilight, civil twilight, nautical twilight, and astronomical twilight time, or true or false, basically, to correlate, because they are very similar. They're only sometimes a few minutes apart. Look at the state and time zone correlate. Why is that? Well, excluding maybe Arizona, most states have the same time zone throughout the whole year, and most states also don't have a time zone that changes. Nevada, for example, is Pacific time zone. Guess what it's going to be next year? Pacific time zone. Guess what it's going to be 4 years ago? Pacific time zone. That's why these two are highly correlated. So, and it does all this automatic reproduction. Tells us a little bit more about what it did. Some correlations by missing values. So again, I'm going to upload this for you. You can play with it on your data set. You can play with it on your own data. Feel free. I will show you one other thing here. Okay, let me just pause and make sure my password's not there. Yeah, my name and password is still hidden. Again, I included some extra code because I know some of you would prefer to work either in Excel or, I mean, if it's a Python assignment, you have to use Python. But you can verify or check some of your assignments or some of your assumptions using this code right here. So a lot of times I'll pull 10,000 rows and just kind of check it. I set it to right now 250,000 and I says, hey, let me download it. I don't know. So what this is going to do is it's basically going to take the data frame and save it to a CSV. You can also save it directly to an Excel or to a Hyper or other things. And basically it's going to call it accident. Then in Google Colapse, it's just going to download it. Give me a second to do this and you'll see why this can be really nice. Okay, so that code, I think it's 3 lines of code, basically take a data frame and shift it to a CSV, which saves on the actual Google Drive. And there's other ways you can save it to a Google Drive and download it to the Google Drive, or you can just have it push it to you and save it. So here is what the sample of the data would look like. So it's kind of nice to actually see what's in the data, just to know what's there. So sometimes downloading a small sample of the data and running it in Excel is helpful to know kind of, hey, what questions are this? Like, do I want to know how many time zones, what time zone has the most accidents? Another one. You know, is icy road a big factor in accidents? To take anything, I don't know. I mean, I know ice freezes at 30 or water freezes at 32 degrees. I'm not sure necessarily road freezes the same thing, but I can take all these numbers and say, hey, anything below 30, we consider ice on the road plus rain, and anything over 30, no ice. So yeah, right here, light rain, overcast. So I could say, hey, if below 30 some degrees with rain or snow, then we can assume there's ice on the road. If not, you can go from there. So that's why I do like sometimes to download 10, 12,000 sets, 15,000 rows, just to kind of get an idea of what the data is about. I just had ChatGPT, close it out, come up with some general questions. For your homework, like I said, it can do there we go. For your homework, as long as you come up with 2 or 3 questions, you answer them in Python, I'm happy. It can be this data set, it can be the accident data set, it can be the flying data set, the car data set. I really don't care. I just want you to be able to understand that, hey, here's how we get data, here's how we load it to a data frame, here's how we either deal with nulls, here's how we deal with outliers. I want you to be able to do some basic stuff there. Because once you can do a few basic things, then you can build upon that foundational work, I guess. What's the distribution of accidents, severities across different states? That's a great question. What cities have the highest number of accidents? What else do we have? Which streets or states have the highest frequency of accidents? And some of this can be literally directly answered from that Pandas profile. Are there any trends or patterns in the description of the accidents? How does the number of accidents vary across seasons? What percentage of accidents happen near amenities like gas stations or junctions? So again, if you have questions, please let me know. This is just a quick demo of the homework for next week and also Python. So thank you again for your time and hope everyone's doing well.